Heat is one of those topics in science that crosses over into other areas. The nature of heat is developed in the Earth Science tape under meteorology. There we learned about the movement of particles as a solid is heated to a liquid and then to a gas. Earlier on this tape, we investigated our sense of touch, and we realized that our skin is really a heat sensor. And all machines produce heat as a result of friction, a very important point in mechanics. And as you plan your unit on heat, you should review these sections if necessary. If your students haven't learned this information yet, you should go back and teach that first. We want to go on now and look at sources of heat. Where does the heat come from? Well, the number one source is our sun, and heat is produced in the sun from nuclear reactions. Imagine this: if the sun were turned off today, the land on our planet would cool off within 2 weeks and we wouldn't be able to survive. But the oceans, the water on our planet, which holds so much more heat, would stay relatively warm for 1,000 years. Heat is also produced by chemical reactions. Whenever we light a match or burn any fuel, we're producing heat from chemical reactions. And whenever we eat food, we're converting the energy in the food that we eat to keep our bodies warm. Heat is also produced in friction in machines, and we can feel heat by rubbing our hands together. And you can demonstrate heat from friction by rubbing a pencil eraser on a table and then feeling the tip of the pencil eraser. Heat is also produced by electricity. It's kind of a form of friction. We're running electrons through a copper wire, and the movement of the electrons are heating the wire up. And then there's the geothermal heat, the heat from within the Earth. And that heat is caused by radioactive elements, which are finally spread throughout rocks in the outer zones of the Earth. Now, to measure heat, you have to have a heat measuring device. Thermometers. Thermometers are inexpensive and they're readily available. There's lots of companies that produce them. This particular one's the kind I recommend. It's got degrees Fahrenheit on one side and degrees Celsius on the other. The students can make comparisons between the two scales. This one uses alcohol as the fluid, and it has a plastic backing. You'll note also that between the tens there's only 5 subdivisions. This means that each subdivision is 2 degrees. Your students will probably have difficulty reading these 2-degree marks. To handle this, give them a drawing of the same thermometer, but with the 2-degree marks actually listed by number. All they need do is mark the corresponding point on their drawing with a red crayon. Not only will they learn to count by 2s, but they'll learn the interrelationship between degrees Fahrenheit and degrees Celsius, and learn to read a thermometer. You can go on to make a large thermometer for a bulletin board. Make it out of cardboard with a center piece of cardboard that slides up and down to read the temperature. And when the students go outside and read the daily temperature, you can set it each day on your bulletin board. It's important that the children gain valuable hands-on experiences using thermometers and recording temperatures. With this in mind, here's another activity for you. You can hand thermometers out throughout the room, one for every 2 students, and have them record the temperature at their location in the classroom. Remind them not to hold the bulb end of the thermometer. Then draw a big rectangle on the blackboard and record all the temperatures throughout the room inside the rectangle. Looking at this picture, the class will see that there's obvious cold spots and warm spots throughout the room. What might be causing this? Could the room really be colder in some places than others? Or is it the thermometers that are inaccurate? Well, how can we test the accuracy of the thermometers? We could put them all in one jar of water at the same temperature and they all should read the same temperature, or we could exchange thermometers and see if we still get warm spots at the same place. There's many different directions we can go with an activity like that. Another thing we can do is set up some lab stations with 3 different samples of water. Sample A, B, and C. A will have hot water in it, B will have warm water, and C will have cold water. Your student groups will go over and record the temperature of each sample. You might have them record the time too, because when they're back at their seats talking about what was the temperature of sample A, then maybe one person measured it later than another and it cooled off a little bit. If you want your samples to be consistent throughout, then bring them in a thermos bottle so they stay the same in all groups. Now we want to go on and talk about how temperatures cool off. We start to see this idea developing. We can take two different samples of water. We'll take a large container with some cold water in it, and we'll take a smaller container with some very hot water in it. And I just put blue food coloring in it so you can see it better. First, the students want to take the temperature of the hot water and then the cold water and record those temperatures. Then they want to put one inside the other and wait 10 minutes. What will happen? You can let them hypothesize if you want. Which temperature will they come to? The cold water will get hotter and the hot water will get colder, and eventually they'll come to the same temperature. They'll stabilize. This is called equilibrium. And by measuring the same two temperatures again, they'll see that this happens. You're talking about heat transference. Then you can go one more step. What would happen if we put twice as much water in here? What would be the new temperature they'd come to? You could go on and try this experiment too. We're seeing how heat is transferring through different objects. We see how it transfers through liquids. How would it transfer through solids? Well, here's another good activity. Get a knitting needle and flatten it out on one end with pliers or a hammer and drip wax on different points of the needle. This one should be done as a demonstration, not an experiment. Hold the flat end with a clothespin to keep from burning your fingers, and use a candle for a heat source. Remember to ask your students what they think will happen before you do the experiment. The wax, of course, progressively falls off as the heat travels through the metal. You might go on and try this with other materials. A piece of wood wouldn't work real good because the wood would catch fire. But how about this? A piece of wood that's wired on to a piece of metal, and I put my wax drippings on each. This time, when the metal's heated up, the wax melts and falls off the metal, but it stays on the wood. By making observations of this experiment, your students should realize that some materials are good conductors and other materials are good insulators. There's two new words. Now, to really challenge your class, you could ask them this question: which metal transfers the heat the quickest? Would it be the steel or the copper? And how might we do an experiment to test it, rather than just hold the ends of them to see which part of my hand gets burned first? Let's put our wax drippings on each at equal intervals. And then let's put them in the flame and time it and see how long it takes for the first one to fall, how long till the second one falls, and then do the same experiment with the copper, and then make the comparison. By doing an actual experiment like that, the students will start to logically see that there are ways to test things, and this is one way to test the rate at which heat travels up through two different metals. They can go on in their groups to do a similar activity, learn about conductors and insulators, get various objects, metal, wood, glass, put it in a large styrofoam cup, and fill them about 3/4 full of hot tap water. After a while, they just merely feel the ends of the materials to see if they're cool, warm, or hot. That'll tell them whether they're good insulators or good conductors. Now we want to go on and we want to take a look at light. Light is closely associated with heat, and it's another interesting topic.